Hello guys, in this video I'll show you a breakdown of how to create this pencil case as well as how to randomize pencil color, shading effect, as well as radius and height and so on. So this is the entire wall graph, and this is a case generator, and this is preparation to scatter pencils inside this pencil generator, and this is a pencil generator itself. This is where randomization happens, and this is where simulation, RBD simulation happens, and this is post-processing. And simulation itself looks like this. So this is a pencil case. In this case, I'm using my code generator, which can be used for this task also. And essentially, it is a line. Then I'm using a sweep mode with a scale ramp, and you need to enable it. And after that, I'm using a polyfill to close top and bottom holes, and then I'm using a split by normals to select only the top face, and then I'm adding a thickness using poly extrude and adding a poly bevel, and that's how you create this case shape. And all of the other things here is where I have added a plate, legs, like that. But essentially, to create the case for the pencils, this is all of the nodes you need. And this part is preparation part, where I want to scatter, where I want to scatter pencils onto. So you need a circle. You need to match the case shape, and to match the case shape, you can use bounding box expressions and scale it down into the x and z axis. So this is before and after, and as well as to move it using a bounding box expression. So this is the default value, so I'm moving the circle onto the very top of the bounding box with the case shape, and then I'm dividing by 4, so it appears almost at the very end of the case shape. And then I'm using poly expand 2D, and this is the result. And this is just to make sure that pencils will be spawned inside of the circle, not on the very edges of the circle. And this is really important when doing RBD simulation. So, and after that, I'm using scattering mode, and I'm scattering 5 points in this case, as well as using global seed to randomize its position, its placement. And force total count is basically the amount of pencils to scatter. And then I'm using a randomize p-scale, which is attribute randomize. And I have exposed minimum and maximum, and I have set dimensions to 1. And after that, I have created for each point for loop. And under the for each begin, you need to add a metadata node in order to access iteration number. After that, I have added a pencil generator, which I have shown in the previous video. And after that, I have scaled it down a little bit for the RBD simulation, and I'm basically copying 2 points. And if I preview everything, this is what the result I will get. And under this now, I have all of the randomization parameters, basically to randomize radius, seed, as well as radius min and max for the amplitude. This is for the shading effect, this one, as well as the offset, element size, as well as the pencil color. And I have used all of these references, all of these parameter references inside of this pencil node. And the expressions is very similar in all of the cases, in all of the other parameters. So all you need to do is to access an iteration number from this for each loop, then add a certain seed value to randomize to control the seed of variation, which is basically this seed, one size seed, and so on and so forth. Then you need to wrap it around a random function, and after that I'm remapping these values, whatever values comes from these functions, expressions, and then I'm remapping it to the minimum and maximum values I want, which in this case is driven by this element mean and maximum values I have here, and that's how the randomization coloring has been done, and other stuff, as well as a shading effect. And after that, I have added a switch node to enable disable pencils. This is really handy when creating a pencil case shape. Choose this one. This is basically to speed up the process of creating a shape before adding simulation. And after that, I have added a simulation, RBD simulation, which is this node with pretty much default values. And the important part here is to, under the collision, set the collision shape to concave. This is the result we'll get. And here I'm using an object merge to reference this shape, pencil case shape. And I have also added an option to collide pencils with whatever object I want to collide them with, and I have exposed it into the HDL level. And after that, I'm using a time shift to basically export certain frame number, which is important if you want to use it inside of Unreal Engine or Unity. And then another switch to enable or disable simulation. Then cleaning up after the RBD, basically removing attributes which I don't need anymore. Then I'm grouping pencils, then merging everything together, then doing a clean. And here I'm unchecking remove diagonal primitives and keeping normals, color, UVs if you want to add them, but in this case I don't have any UVs. And then I'm keeping an Unreal material, which I also don't have in this case. Then I'm using normals and using this group, which is basically group pencils. You can also use a channel reference and the group plot, which is basically this pencil case. Then I'm adding a collision geometry, and this is a name. This is a group name which Unreal Engine and Houdini Agent will recognize. And that's pretty much it. And I have also added Unreal Nanite support, and to enable it. And to add it, you need to type Unreal Nanite enabled, and the type is need to be set to integer, but in my case with the float it's also working. And the value and default value I have set it to none to basically to enable it. Let me increase the number of pencils, and I don't need this anymore. And I need to reset simulation, and here is the result we have. And I also can control the color of each pencil. And disable them also. And yeah, and this is how you can create a pencil case generator. Hope you found it useful, and see you in the next video. Take care.